I can fight monsters, I can't fight physics.
Hello, Ziad. So this is question 5 of June 2023. So figure 7 shows robotic helicopter used on Mars. The helicopter is powered by a battery before each flight. Battery is charged by solar panel. Shows helicopter. That's just fluff. So figure shows helicopter hovering at constant height above the Earth's surface. Above the Mars surface of Mars. The rotor blades move a column of atmospheric gas vertically downwards at a velocity of 17.2 meters per second. So the diameter of this column is 1.2 meters. So basically, it pushes down this much air, okay, which looks like a volume of a cylinder, doesn't it? So that's just pi r squared L. Now, what would L be in this case? In 1 second, L would be 17.2 meters because it's 17.2 meters per second. So let's have a look at the question. I think that's going to be pretty much what we're going to ask. Gas moved by the rotor blades has a density of, so they give you the density, show that the helicopter moves approximately this much, so it's M, every second. So every second, L is 17.2. So you've got to use density is mass over volume, or mass is rho V. We've got to work out V, so V is, because it's a cylinder, it's pi r squared or pi d squared over 4 times by L. So we just got to put our numbers in. So pi times, now d was 1.2 squared over 4 times 17.2. So when you can work that out. So then once you've done that, that equals 19.45. Then you just put that into here. So 0.02 times 19.45. Okay, so when you put that in, let me just quickly work it out. So, oh yeah, so it's 0.389 kilograms every second. So that's the mass per second. So that's nice and easy. So the movement of the gas creates an upward force on the helicopter. This upward force enables the helicopter to hover at a constant height. So if it's hovering, that means the upthrust is equal to the weight. And the weight is equal to mg. Now you've got to work out the upthrust. Okay, so how do you work out the upthrust? Use Newton's third law. The upthrust is equal to the force downwards by the propellers. Okay, so can we work that out in any way? Well, we just worked out the mass. They've asked you that for a reason, haven't they? So therefore, if you use mv minus mu over t is equal to the upthrust. So mu disappears because u was 0. So you've got the mass that you've just worked out. So that is 0.389. Times by V, which is 17.2 over 1. Okay, so let me just work that out. So that gives me 6.69. So that's your upthrust. Okay, now this upthrust is now equal to the weight because it's balancing it, isn't it? So that's equal to mg. G is 3.72, so M is 6.69 over 3.72. So if I divide that by 3.72, so that gives me about 1.79, so 1.8 kilograms. So hopefully that answers that question for you.